Yeah, thank you. Yeah, so Dials is awesome. There's a lot of awesome software out there, but it's a real pain to type. So we've been helping people with that problem since 2009 when we sort of initiated the RAPD project. And this is the basic flow of my talk, and hopefully we'll get through it all, including a live demo, just for brave souls out there. So what is this RAPD? It's an acronym, of course, for Rapid Automated Process Data, most of the time. It's pronounced rapid, not, pronounce it the way you want. It's okay, that's safe for work. So in 2009, we really saw a lot of users weren't calculating strategies, or they were calculating strategies that take a long time. You have to turn your chair, and you have to type on the computer, and then you have to talk to 3 people about it. So we wanted to create strategies as fast as possible so people could collect data properly and be encouraged to do so. So we originally used the eDNA project. I think that's how it's pronounced. It might be Edna. I'm not sure. And it was a nice project. It would produce strategies. But as soon as we sort of wanted to tweak it to do something a little different, it was very difficult for us. And the reason it was difficult for us, I think, is we're not software engineers. We started this project. I knew Python relatively well. No one else had actually typed any Python into a computer, I think. So we didn't really know what we were doing. And we decided to sort of homebrew our own solution and to handle what I call edge cases. Of course, edge cases, if you're in production and you're processing a lot of images, edge cases are just everyday appearance. There is no such thing as an edge case. And our goal from the outset has been to handle 99% of data that Raj can handle. I think we're getting there. I think we're around 95% of the data Raj can handle. So unfortunately, I multiplied 99 times 95. That means we're only 95% of the way there, but so we're getting there. And somebody pointed this, I think, it might be Raj pointed this. He's like, I don't think you should call it a pipeline, because pipelines imply that you have basically you're putting things together and it's very smooth and it just runs. And okay, so it's not a pipeline. So maybe call it an agent. That sounds good. It's not technically it's an agent if you're in computer science. And are you really selling people a bill of goods, or what kind of agent are we talking about? We're selling insurance. I can assure you that your data will be good. You're not really doing that, and you don't be that kind of agent. It could be problematic. So what kind of agent? Now this is sort of what you're going for. I mean, and I originally this was actually XDS, but someone pointed out it should be a British program. So you have to. This is the way you can think about yourself. Rapid is the agent, or it has the agents, and they're getting into their nice cars that are XDS or pointless or whatever they're using. And we really feel like, of course, without the programs, you can't write the agents that run the programs. So they're invaluable to us because there's no way we can write Dials or XDS or pointless. So what agents do we have right now? So we have the auto-indexing strategy, the original agent, and then we have integration analysis, simple merging, where you can just take 2 data sets and put them together, and then you can add a third and sort of keep going from there. We call that the simple merging. And then SAD and MR, and a crystal orientation agent, which uses stack that came out of SRF. So the teams are important. You can't do it without them. So you met John. A lot of you have probably met most of these people. So John and David write most of the pipelines. Kay helps. She has a new pipeline that's come out, that will come out. Surajit wrote the simple merging pipeline. And then Jim, of course, is the guy that, you need a server or you actually need something to run, or perhaps an IP address would come in handy. He's the guy to talk to. So that's the team that's really put it together. And, a project like this takes a lot of work, and it takes a lot of people communicating and committing, actually, software changes. So you can see this is the commits. It started in 09, but we actually finally got version control in 10. And you can see it, there's a lot of activity. This is almost 500 commits, and this is, I'm guessing, February or January of 2012. So we're down that month. So you get a lot of commits on down months. So a lot of people put a lot of work into it. And you can see now we're sort of in maintenance mode. I think Rapid, the version we're under, is sort of coming to an end. And Hopefully it just keeps running for another year or so until we can get something to replace it. So the real stuff, auto-indexing strategy, which we heard about earlier. And so you can see that it's complicated. And so I haven't run an actual auto-index in a long time. Oh, I taught a class this year, so I've done one this year. But I run it once. Usually I use Moscone because all the students can get it, and it's pretty easy to run. It's straightforward to use. So I hit, auto-index, and it does an auto-index. But you're only doing one. So originally I think we only had one, and then we ran into a so-called edge case. So then we had two, then we had three, and so do you really need 6 auto-indexing processes? So what it's doing is it's actually looking at it, comparing them, figuring out the best one, things like this. So this was a question actually yesterday. So do you need all 6? So I looked at it, and these are the 6 different instances, and you can see that, and this is all successful auto-indexings by RAPD in the last 5 years. And you can see that it has selected at different points in time every single different iteration that it's used. So apparently you do need those to really capture all those cases. And how many runs do we do? So this is these are single frames, and then people are encouraged to take pairs of frames, and they're almost inevitably 90 degrees apart. And so these are the pairs. So, last year we got up around over 200,000 auto-indexing agent runs. And that's, of course, if you're running 6 labelets on each one, you're running labelet 1.2 million times or something insanely crazy like that. So it helps to have a cluster to keep up with things like that. So then we expanded our mission, and we wanted to add capability. So we wanted to add integration, obviously. That was, okay, you've got to add integration. Because I think Zia 2 existed at this time, and it's very nice, Zia 2 is good, and we tried it, and it was too slow, so we ended up having to homebrew our own thing. And then we wanted to add SAD and MR and simple merging. Oh, did I miss something? Yes. But we want to keep the focus, and it has been, on assisting users of the beamline. So we want to assist people primarily at the beamline, and then it sort of grew to we also want to assist people after the beamline. So people can access RAPD from home. They can, you'll see people launching processes a week or 2 or a month later. And we want to help people make the most of the beamline. So integration analysis. So the agent design looks very, very simple. It's very, because what else do you have to do? So of course, the arrows are is what David has worked on so hard to get it to work. And the arrows is a lot of hard work. So just implying that, you just strap XDS to pointless and aimless, and it just works. Of course, that's not true because the fraction is not always Thaumaton. Sorry. So it's very complicated. And, if you look, same slide twice. If you look at this, there's a lot of frickin' arrows in this diagram. So there's a lot of logic that's going into launching this, figuring out what's the best thing, falling back. So sometimes BEST will not give you a strategy. So you have to run, and I think BEST gives slightly better strategies because it uses a different algorithm. But, if you need a strategy and BEST can't do it, Moscone is a perfectly good geometric strategy. So we can use that. So what integration agent gets it out to the user? So the other agents, so not on an auto-index, but the other one, integrations, we're up around, 18,000 integrations last year. And you'll see that these are the little guys, right? The merge, the SAD, and MR. And the reason they're the little guys is because those are actually launched by users. So auto-index and integration are launched automatically on all the data, of course. And then the computer doesn't know what's molecular replacement. The computer doesn't know yet what's SAD, what's actually going on, what needs merged together. So the users are left to do that. And of course, users, people don't try things in an exhaustive manner computer-based. So going forward, we're going to look into say, okay, you come in and you're like, oh, this is my project. So the computer can then sort of sift through that data in a more brute force method and figure out what's going on. So a live demo. This is exciting. Okay. So let's see. I think there's a web browser on this computer. Yes? No? Where are you? Aha. So there it is at the bottom. So I'm an admin. If I do this, does it show up? Oh, look at that. Okay, so I'm an admin, so I see all the different users. So there's almost, 2,300 different trips. So we organize by trips because we're a beamline. And I will show you something safe. Oh, see, look at this. It doesn't like my JSON. So what it needs is, it's been sitting here too long. There we go. See if it likes that. There we go. So this is a class at Cornell. And so they collect data remotely. And you can see there's lots of snaps over here. And if I click here, there's lots of runs. Well, not so many runs. So snaps, so I'm going to pick, I think A4 was good. It was a good example. It doesn't really matter, so any of them. So this is, a single. You get your data. You get what you need on the back of a thumbnail. Here's your space group. Here's your data collection strategy. Here's anomalous data collection strategy. Sure. Detail. Do you need this much detail? If you really, if things are not going well, you can get it there. So one of our philosophies is provide what people need quickly and then provide what they might need somewhere else. So they can get to it if they really want to drill down, but usually you don't have to drill down. This is brominated, so we actually want to look at the anomalous data. So this is where to start. It marks right here where it's suggesting you start in the first page. Is it good? You can look very quickly. The plot that 10% of people look at that they need to look at on an CCD beamline, especially, is the maximum oscillation width. This one usually takes a little explaining. But then, you can go ahead and, with your strategy, collect a run. So where's a run? Here's some runs, and you can see they've got little sort of like Sherlock Holmes magnifying glasses, which means they've been solved. So if we look at the summary of a run, you can see that it basically has, I don't know, maybe table 1 and table 1.2 or something like this. So it gives you the data you need. I think I'm always a fan of giving people only the data that they need, but we have to sort of, different people want different, people still look at our merge, it's hard to break old habits. So this is giving people the information they need. And you can make a lot of decisions based on this data. Perfectly good. Again, you've got all the data. You can look at the pointless, the aimless, the integrate, the correct. And, it's not run, it looks like it's only run XGS once. It's probably run XGS 3 times at least on this data set to get the parameters just right, copy your GX parm, things like this, just to get things the way they should be. So plots, I usually skip the detail and go right to the plots unless I have a problem. And, you can look for radiation damage. So whoever taught these students to collect data did a good job. They don't have radiation damage. You can look at the information you need. We even have RD, which most people don't really understand what RD is, but it's another indicator of radiation damage. So you can go and look, get all the information you need. This tab, the analysis tab, is the most information-filled tab, I think, because it gives you information like, have I automatically solved your structure? So frequently, you're you're working on a project that's already in the database. So this will go out and very simply, look for the cell edges in the database, download the closest, I think up to 10% if something's not very similar, and try molecular replacement on it. So you can literally just go here and download a solved structure. Obviously it's phomitin, pretty easy to do. But also, if you have problems, which people occasionally have problems, it runs X-triage, all the good stuff on it, runs the plots. This is anomalous, so we're really interested in this plot. Looks great. So go ahead and, I want to solve it. So I'll go ahead and right-click. Let's see if I can right-click with this one. How's right-click set up? No? Right-click's not set up on the, okay. Maybe command, is it command? Any Mac people know? Mine's too, it doesn't matter. So I can right-click, ask it to do SAD or MR. So some people, I said they should do molecular replacement. If you do molecular replacement, it gives you anomalous difference Fourier. So there's some people who bring projects where they want to see metals in something that they know they can do molecular replacement on. So that gives you a nice answer. You can see what happens in molecular replacement does an exhaustive space group search. So this should work in P41212. There it is. SAD is a very nice agent. See, I keep using Python. I can't break the habit. And
what it does is runs SAD the way you would run SAD. It runs shell XC. And everybody, I think, runs HKL2map for the most part if they do it by hand. And this gives you, we want to make it so you understand what's going on, so you get results that look like HKL2map. And this, of course, is thaumatin, so it worked really well. It was brominated. So this is what you expect, and this is what people want. So those are the big pipelines, or the big agents. And we found that people really like getting solved data sets for minimal effort. I think it's great. It's actually a lot of fun to see people realize for the first time that they have processed data. I think I encourage people to take the data home or a lot of, I guess most of them are already home already, and go ahead and see if they can do better. The scripts, are already there. The XCS script is there. How do you, go ahead and modify, take that script, modify it, see if you can beat the computer a little bit. Most data sets you can't, but, I think it's a good idea. The other thing is that there's an iterative aspect to this. So we don't have automated methods for going in and marking data sets as problematic, but usually what the agent writers will do is they will look and say, okay, who's on C today? They'll look, and this data set didn't process correctly. What's wrong with it? Should it process correctly? Okay. I'm going to fix it so it will. And that's sort of how we've pushed it out to better, more and more robust systems. Okay. So, of course, I've been dropping these hints that it's old and aged and things like this. No offense to anyone over 40. But the plan, of course, is to move to RAPD2, because as you know, you don't get that much credit for something you wrote 5 years ago. You have to write something new with a new name or a number in it. And, I noticed I was trying to think, okay, well, how old is it? It's, it's older than the iPad. So that's like Ice Age, I mean, it doesn't even run on the iPad. It's just awful. So you can't do that. It probably doesn't run on an iPhone either. So the other reasons are it's tedious, difficult, or impossible, depending on my mood, to add agents. So agents are very, we originally wanted to make the framework to be very flexible. You can take it and do this, and of course it starts that way because it doesn't do anything, and then it does a lot of things and ends up very, very brittle. It's very difficult to add to agents. I think John made reference earlier to a SAD agent that he wrote, and I still haven't got it in because it's a pain, We've learned a lot in 5 years. I think a lot of people now that are writing this know a lot of Python. We know a lot more about the web interfaces, what's current. There's a lot of new tech out there, especially for the web. Dials. There's a lot of new X-ray tech out there. And it's going to be simpler to start from the ground up than remodel old software. There's no way I'm rewriting PHP code. It's just not going to happen. So an example of a new agent is Kay has been working on a new agent for the last year or so, and it's using this hierarchical agglomerate clustering. And so there's a couple groups that are writing things like this. So if you have a bunch of data sets, a bunch of partial data sets, or even a bunch of full data sets, and you want to merge them together, you can merge by hand. Of course, can be problematic. So what we came up with is a way to combine them very quickly using by a linear correlation coefficient. And it's very fast. So you can go through and, do something like this in, a matter of 60 seconds. So you can compare all your data, and it'll basically pump out all these different small subsets of data and then give you what you need. We want to get into RAPD, but we want to build, we can just make it launch and give you something back, but we want to make it more interactive. So you can set, there's a couple of different settings that you could modify. Set it so that it'll actually give you feedback on what's going on. So we want to make it more interactive that it's possible to do in the current framework. So it's good for things like multiple crystals, even different ligands. So I guess this green actually are soaked with a ligand and the blue are not. It's even good it'll sort out multiple proteins. So if you don't feel like labeling your tubes, just, throw it on there and see what happens. Don't have to write everything down. So there's some new proposed use cases. So right now we run at RB1. And to be honest, I'm glad it runs at our beamlines, but I'd really like it to run at other beamlines, just because, I don't know, jealousy perhaps. But so we could take it and run another beamline. There's been some demand for home source, so there are still some people with home sources. It's crazy. But it'd be nice to then, it's all done for us. There's been some labs say, I'd like to have it running in our lab. So if you have it in your lab, you could bring data home from somewhere and drop it, and it'll just go through and chug through your data. Or you could have it on your desktop, or probably not iPad, but maybe on your laptop and say, I have it running, just like Phoenix. You can do Phoenix Refine, right? Or label it auto-index. So you could potentially do, rapid integrate this data set, and you could use it as a one-off. And then there was a suggestion, because I get all my best ideas from other people, as probably all of you are the same way, I would guess, to use it as a data archiving tool. So we have a ton of data, and every down, somebody goes through and says, this drive is almost full, so we have to move this data over here, or this data is 3 years old, we're not going to keep that anymore. So things like that. But how do you keep track of that? Well, somebody writes it down. So what if you could say, I want to move this over here, and I want to move this here, and get rid of this. So, it's not on DLT drives anymore. So you can maybe manage it that way. And we're always looking for new use cases, especially when you're in the planning phase, because it's nice to talk about use cases when you're planning. So the implementation ideas are to have it fully flexible and adaptable. Things like roll your own agents. So I want to write my own SAD agent. Screw this. So you can start it out, and it'll actually give you a framework for writing your agent. Put this code here, put this code here. Isolation of site-specific configuration. Always a goal in programming, very difficult to maintain, but I think that's going to be one of the biggest efforts to go into the new software, because it'll let you take it anywhere. The other idea is to use the same underlying framework. So if think of going from a beamline all the way going to a desktop, they're very different use cases, but I think you can basically modify the same framework for running those cases. At least I think that works. We want to basically take the lessons from Rapid and Remote and mix them in with some new tech and sort of mishmash it all out and see how it works out. And we want to have things like our automated test framework. I know everyone's had the experience where somebody changes a little software. That's fine. It's just a print statement, and boom, the beamline goes down. So the idea is to have a framework so you can actually say, okay, Rapid comes with this much test data. Go ahead and run on your install, and it'll all, it can integrate, it can do SAD, all that stuff. And then the other thing is for community contribution. So if you're going to support, 50 different beamlines or anywhere you want to collect data, it'd be useful if, somebody sitting here at Harvard, it's like, this is a new detector, and works out how to configure for it, and then they can just donate that back to the project, and then it's just sitting there. So that's the kind of thing we want to look into. So we can maybe collaborate more with everybody, so it'll work better. So it's in initial planning. We're working on build scripts that will actually help show you, build the project out. I've talked to the guys at SBGrid. They're helping actually plan that out because they have a lot of experience with that. So I don't know. I don't even have a timeline for it, to be honest, but hopefully next year. Let's see. So acknowledgements. So I was sitting, in the lecture, and I was trying to think of all the programs that are used in Rapid. And of course, I used some cheats by putting CCP4 because that covers a lot of programs. But yeah, we use a ton of really great programs out there, and couldn't do it without them. So hats off to the developers of that. And thank you very much.